Hello, this lesson is 8.4 and it's about the volumes of rectangular prisms. The essential question is, how can we find the volume of a rectangular prism? So you may have learned about this already in 5th grade, right? So it says, recall that the volume of a three-dimensional figure is a measure of the amount of space that it occupies. And volume is measured in cubic units. A unit cube is a cube with an edge length of 1 unit. Now maybe the unit is a foot, right? Can you picture a foot? In 3 dimensions, right? That occupies a pretty big space. So it would be 12 inches by 12 inches by 12 inches because every 1 foot is 12 inches. So picture something like that, right? And so as your units get bigger, I could move up to yards. And I would be looking at something that is 1 yard by 1 yard by 1 yard. And then, of course, when you start talking about cubic miles, right, that gets even bigger because it's bigger in 3 dimensions. So we're learning about volume, and I just want you to know that volume has 3 dimensions. That's why we're talking about cubic units, because in that space, you're trying to figure out how many cubes will fit inside. Okay, so the key idea is on page 376 of your textbook. And notice that there's, words and there's algebra, and it might be a little confusing because there's 2 different formulas. Most of the time, we're just going to think about volume being length times width times height. You can't go wrong with that. And then the other formula that has capital B times the height. That formula, this is more of a universal. So I'm going to say universal means everywhere out there in the universe. If you use the formula of capital B times the height, it's going to work for other 3-dimensional figures. Okay? But when we're working with rectangular prisms, it's like a box that has a length, a width, and a height. So that's what we're going to concentrate on today. This will be for later, right, in your math career when you're looking at shapes that aren't quite as easy to understand as a rectangular prism. Okay, so there's a red star here, right? So you're going to pause the video and fill in the notes for finding volume of a rectangular prism. And it's super basic, right? We want to keep it easy. Basically, you multiply the length times the width times the height. Those are the 3 dimensions of a rectangular prism. And then remember that volume is measured in cubic units. Because if you could cut this into the little 3-dimensional pieces, you would be counting the number of cubes that it takes to fill the inside of this box, right? And I made it by 2, so I'm going to kind of do that. So we would be counting the cubes inside. It's cubic units. You are literally counting the number of cubes that fit inside the shape. And then the formula that we're going to use is length times width times height. Now, you know I don't like to use x's when we get to the sophisticated equations. So most times you'll see it written like that. But I decided to go ahead and put the x's for multiplication just so that you remember that variables next to each other means multiplication. Okay, so these examples aren't in your textbook. So this is taking us back to 5th grade when you may or may not have learned about rectangular prisms in 5th grade. And so I was thinking there was 2 ways to handle this type of a problem, and we could use some math sense and logic. So I'm thinking if you look at this figure and you try to count the number of cubes, right, the total cubes that make up this 3-dimensional shape, you could start with this, right? There's 4 by 7, right? This is 4 on the side. You see 4, and then you see 7 in the front. So if I cut through and just looked at the bottom layer, there would be 7 times 4 or 4 times 7. There's 28 cubes in the layer. And then as I went through and I counted the layers, there's 5 layers. So you could come up with 140 unit cubes to fill up this shape. So I could say that the volume is 140 cubic units, right? That totally makes sense. But now, if you're the person that likes to think of it as a formula, the formula is length times width times height. So I could plug in those numbers, right? Oops, let me go back and do that. So the idea is, depending on what you consider the length and the width in this equation, this was the width, this was the length, and then the height is over here, and it's 5 units tall. So I multiply 4 units times 7 units times 5, which gives me a total of 140 cubic units. So the OYO for you is to find the volume of these rectangular prisms, right? So you're basically using the formula or using the logic and common sense to find the total number of cubes that make up these prisms. And it says label your units. For instance, if you did this, I would say that the length equals 1, 2, 3, 4, 5, 6 units. I could count this as the width, 1, 2, 3, 4, 5. So I label the width as 5 units. And I label the height, 1, 2, 3. And I write h equals 3 units. That's what I mean by label your units. Go ahead and pause the video and calculate the volume of these rectangular prisms. Okay, so I'm going to write the formula, volume equals length times width times height, and then I'm going to plug in 6 units times 5 units times 3 units. I can only multiply 2 numbers at a time, and when I remember units times units is units squared, so I get 30 units squared times 3 units. And remember, right, I do multiply the units, so 30 times 3 is 90, so I get 90 units squared. Here's another, so now this is units to the 3rd power. Well, that's because there's 3 dimensions. So the volume is 90 cubic units. If you count all the cubes that it took to make this shape, there's 90. Okay, so I'm going to go ahead with this one. 1, 2, 3, 4, 5 units. Oh, sorry, this is length, and this is my width, 1, 2, 3, 4. My width equals 4 units, and my height is 1, 2, 3, 4, 5, 6 units. And I write my formula. It just helps me remember it. Length times width times height. So it's 5 units times 4 units times 6 units. 5 times 4 is 20, and unit times unit is unit squared times 6 units. And then when I multiply 20 times 6, I get 120, and it's units to the 3rd power. 120 cubic units. All right, the last one, 1, 2, 3, 4, 5, 6, 7, 8. I have length equals 8. 1, 2, 3. I have width equals, oops. It's not erasing. There we go. Width equals 3 units. I forgot to put units there. And my height, maybe I'll put it over here. 1, 2, 3, 4. H equals 4 units. I'll write the formula. Length times width times height. 8 units times 3 units times 4 units. 24 units squared times 4 units. That means there's 4 layers of the 24, which gives me 96 cubic units. Okay, so that is supposed to be a review, but basically remember that volume is the amount of space that is taken up by that shape. Okay, so now what if our unit cubes were fractionalized? What that means is, right now I have a picture of a unit cube, right? So here's my unit cube. So what this means is, instead of having one single cube, I'm going to take my 1 unit and I'm going to cut it up into smaller pieces. And when I do that, I'm going to cut the, let's see, let's call this the length. Am I on my pen? This could be the length, and this could be the width, and this is the height, right? So what I'm going to do is I'm going to cut the length into two pieces. And so when I take one of these little cubes, I basically am taking the length, I'm cutting it in half. And so the length becomes 1/2. Now I'm just going to take out one of these little three-dimensional cubes. And the same thing with the width. I'm now going to cut the width in half, and I'm going to cut the height in half. So if I take this little cube out, what I want to know is, what are the dimensions of this cube? Well, hopefully you're seeing that the dimensions of the cube, because I took something that is 1 in length and I cut it in half, the dimension of the cube is 1/2 and 1/2 and 1/2. Oops, let's move the height over here so that you can see it. So the height is 1/2, right? So the length is 1/2, the width is 1/2, and the height is 1/2. It's 1/2 of what it used to be. And so if I start to take this shape apart, it's really cool, right? You can start to see, ooh, there's 1, 2. I wonder how many of these little cubes fit inside. I have 1, 2, 3, 4 in the top row, and I can see 1, 2, 3, 4 in the bottom row. So now, if I figure out this little cube that I've cut up from the main cube, which was 1 unit in every direction, I now have a total of 8 cubes, right? I have 1, 2, 3, 4, and I moved these. Let's keep the 5, 6, 7, 8. So these cubes were 8, right? So it took 8 of these cubes to make a whole. So it makes sense that if it takes 8 cubes to make a whole, that this cube must be, my new little cube must be 1/8, right, of the whole, okay? So the math that you can do to make that make sense is, oh my gosh, the volume of 1 cube now is 1/2 times 1/2 times 1/2, which is 1/8, right? So I'm going to put that over here because it's kind of going to match the picture now, because I'm picturing that when I cut each side into half, 1/2 times 1/2 times 1/2 is 1/8. So 1 cube now is 1/8 of the total. So I want you to see this, that each cube is 1/8 of the unit cube, and it takes 8 to make the whole entire unit. So now, if I find the volume of just this little cube, I really am using the same formula, but instead of whole numbers now, I have fractions. So I want you to think about, it's the same formula. It's length times width times height, and it works even if the cubes are fractional pieces, right? Okay, that's the idea. So now we're going to do an example where we find the volume of each prism. And I'm going to label this the length, and this will be the width, and this is my height, right? So now all I'm doing is the same idea with whole numbers, but now I have fractions. It's a little bit harder to picture, right? So you should notice that this cube, if I look at the volume, because this is less than 1, this is less than 1, and this is less than 1, my volume, my total volume, it takes less than 1 cube to make it. So when I multiply and get a fraction, it better be less than 1. Okay, so now I have this kind of set up to go. So the idea is length times width times height, right? And the volume, the length is 7/8, and I could put parentheses, 7/8 meters times, 1/2 meters times 5/8 meters. Okay, now when I multiply, oops, I want to grab this. I'm multiplying fractions. Remember, I multiply across the numerators, and then I multiply across the denominators. This is kind of weird because I'm multiplying 3 numbers at a time, but it's also kind of fun. So watch what happens, right? I just do this. I do the 7 meters times 1 meter times 5 meters, and then I put it over 8 times 2 times 8. The bottom doesn't have any units because the units are attached with the top number. Okay, So when I multiply across, I get 7 times 1 times 5 is 35. And then 8 times 2 times 8 is 128. And remember, when I multiply the units, it's meter times meter times meter, which is meter to the third power. This is a three-dimensional figure. So there's my answer. This cube takes up even less than half, right? It's a small cube. It's 35/128 of a cubic meter. All right, let's look at the next example. Now you're going to notice that sometimes you've got some fractions that are bigger than 1. So remember that 4/3 is equal to 1 1/3. So this is a number that's bigger than 1. This is less than 1, and this is less than 1. But we're going to do the same thing. We're going to picture length times width times height. Okay, and then I just use my formula. Volume equals length times width times height. And I plug in 4/3 of an inch times 3/4 times 4/5. And then I multiply all of the numerators, right? And then I multiply the denominators across this way. And then I have, oops, sorry, it's not moving down. 3 times 4 times 5. Now here's the cool part. I'm going to look to simplify before I multiply. If I notice a 4 and a 4, right? If there's 4 in the numerator and 4 in the denominator, I cross this out and I replace it with a 1. I cross this out and I replace it with a 1. And then I can cross the 3 out and I can cross the 3 out. When I multiply across, I have 1 times 4. And on the bottom, I have 3. Oops. Pay attention, that was a 1. I simplified. I have 1 times 5. I end up with 4/5. And inches times inches times inches is inches to the third power. Okay, so now here's an OYO, right? I'm going to ask you to find the volume of each of the prisms. Remember, you're just using the formula volume equals length times width times height. Now you might want to take this 1 1/3, and my hint is that 1 1/3 is the same as 4/3, because remember, when you're multiplying fractions, you can't multiply with a mixed number. You want to use an improper fraction. Okay, so here's what I do. Sometimes I like to mix the formula up a little and just do something like this. Length is, I'm going to turn this into a fraction, 1/1 feet. And I'm going to multiply the length times the width, which is 4/3 of a foot. And then the height is 1/2 of a foot. Now, order of operations, right? I can do the first two multiplications first. 1/1 times 4/3 is just 4/3, which is 4/3. Feet times feet is feet squared. So I have 4 feet squared times 1/2 of a foot. And that means I'm multiplying 4/3 times 1/2. 4/3 times 1/2. And remember that feet squared, and then I have feet to the first power. My units are going to be cubic feet, which you probably knew anyways. And then I'm going to simplify before I multiply. I notice the numerator and denominator are both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So now when I do the math and I multiply across, I get 2 times 1 is 2. And I get 3 times 1 is 3. So I have 2/3 of a cubic foot. That's how much of this box contains of a cube. It's actually not a full cubic foot. It would be 2/3 of a cubic foot, if you can picture your foot in 3 dimensions. Okay, so the next one is length is 3/4 of a yard, the width is 3/4, and the height is 3/4, right? So this actually is a perfect cube, and I'm going to write that the volume equals length times width times height, and then I'm going to plug in by 3/4 of a yard times 3/4 of a yard times another 3/4 of a yard. I'm going to multiply the first two together. I get 3 times 3 is 9, and 4 times 4 is 16. I get 9/16. Remember, yard times yard is yard squared. And now I'm going to multiply by the third dimension. 9 times 3 is 27. 16 times 4 is 64. And yard squared times yard to the first power, right? So I've got 9/16 of a yard in each layer. And then I'm going to multiply it by 3/4 of a yard, and I get 27/64 yards to the third power. This also is really hard to picture because it's less than 1 full yard. So it's a fraction, right? So you can think about if you have less than 1 in each of these fractions, every time you multiply by a smaller fraction, it keeps getting smaller, like this. 1/2 of 1/2 equals 1/4. Picture a half of a pizza and somebody eats half of the half. They've eaten 1/4, right? So when we keep multiplying fractions that are smaller, our numbers are getting smaller. So don't be confused by the fact that there's a lot of fractions going on. Okay, so before we come to the last idea, I want you to think about what happens if you have a missing dimension. And I'm going to start with a missing dimension in a two-dimensional space, right? If the area of a parallelogram is 18 square feet, how can you find the base? And I hope you're thinking that a parallelogram is just like a rectangle, and you multiply the base times the height. And if you know the height and you know the area, you can take the 18, right, and plug it in for the area. And then let's use a different color. You can take the height and plug it in for that number. And then you get something that could look like this. The area is 18 feet squared. So 18 feet squared is equal to the base, which is unknown, and the height, which I do know, right? So now I've got an equation that says area is equal to base times height. So here's how I start out. I use the area formula. I write base times height. But instead of the area, I plug in the number that they, oops, sorry, I'm going to do this in red. I plug in the red. I plug in the number that they gave me for the area. I plug in the number that they gave me for the height. And then I think about what times 3 equals 18. Now remember when we solved equations, what we did with that? We drew a balance scale like this. Oops, sorry. We drew a balance scale like this, and we looked at the side with the variable, and we said, what's the opposite of multiplying by 3? And that would be dividing by 3. And I divide both sides of the equation by 3 to solve for the variable, and I get 6 feet is equal to b. So I solve for a missing dimension by going back to the equation and plugging in all of the information that I have and realizing that I just had to think about what times 3 equals 18. Okay, so we're going to do this in 3 dimensions. Ready? Here is a picture of this computer tower. Oh my gosh, you guys can't even remember when they had computer towers, probably. When you used to buy computers, you had to, it was called a CPU. Okay, so this is how old I am. There was this big CPU thing that you had on your floor, and then you could put your little display and your monitor on top. And this would always sit below your desk. And this was where all of the hard drives were, and there was a little place where you would stick in discs. And it's not like a little CD, it was actually this big floppy disk. But anyway, so this is called a computer tower. Now here's what they said. They want you to write and solve an equation to find the height of the tower. And of course, they're giving you some information, right? So they're giving you the volume. What is this measurement 16 here? If I look at this, I would probably call, well, I might call the 7 inches the length, and that's how wide it is, but it kind of seems like it makes more sense in this one to say that this is the width and this is the length of how long it's going to be. So I could call it 16 inches the length, 7 inches is the width, and the height is unknown. But I know the volume, right? So the idea is I can write my equation just like I did with the previous example with area. But now I have 3 dimensions, right? So I write the formula. It's volume equals length times width times height. And now I remember that, oh, that's right. Oops, let's see. I'm going to change this to red. The length is going to be substituted in for the length here, right? That's my red. And the width is, let's make the width in purple. So the measurement of the width is in purple. And then they gave me the total volume. Okay, I'm going to do the total, like I already did in blue. Let's do that. Total volume in blue is there, right? So I take each of those 3 numbers that I have. But remember, and maybe I'll do this one in green to make it stand out, this is the unknown number. So I go ahead and I'm going to plug in my blue number, which is 1792 inches cubed. And then I'm going to write equals. And then I plug in the red value, which is the length, which is 16 inches. Okay. And then I plug in the purple, which is 7 inches. This is the width. Oops, I didn't mean to write width, I meant to write inches. And then the H is unknown. So now I've got my, oh, it's just like the formula. Volume equals length times width times height. So now what it makes sense to do is use the order of operations and multiply these numbers together. And when I multiply 16 by 7, I get 112 inches squared. Remember, because inches times inches. This side just stays the same, 1792 inches to the 3rd power. And then, of course, I still have my times h. Okay, so here's what I want to do. I want to look at this equation and I want to solve for h. H is being multiplied by 112. What's the opposite of multiplying by 112? That would be dividing by 112. But I'm going to use units just to get you guys thinking about the units canceling out here. Okay, so now the 112, those cancel out. The square inches cancel out. Ooh, that leaves me with the h on this side, and now I just need to do the math of 1792 divided by 112. And what I get is I get 16. So I get 16 now equals h. Okay, so this is looking good, but I want to put some units here, and I'm going to show you that the units are really cool, that they cancel out as well. Inches to the 3rd power, this is kind of weird, but think about it. It's inches times inches times inches. Inches to the 2nd power is inches times inches. Remember, inches and units cancel out just like numbers do. Inch on the top, inch on the bottom, inch on the top, inch on the bottom. That leaves me with units of inches, which I knew I needed because the height is going to be measured in inches. So there's my final answer. The height, the missing dimension is 16 inches. Okay, so now you have an OYO, and I want you to try these last. This is the last part of the notes. Try these on your own. Notice on this one, the length is missing, and on this one, the width is missing. But you always start with your volume equals length times width times height. Okay, so go ahead and pause the video and solve for the missing dimensions. Oh, but I'll tell you that the hint that I'm going to put here, of course, if there's a fraction and you can easily change the fraction into a decimal, right? You just want to go ahead and use the decimal. It'll make your life easier. Okay, so I'm going to start out by labeling. This is the length. This is, oops. Let's do the width in red, and I'll do the height in purple. So when I write my formula for volume, I'll say volume equals length times width times height. But instead, let's see. Oh, I'm going to put that in black. So here we go. 72 inches to the third power equals, the length is unknown, it's in blue, and the width is 6 inches, and the height is 2 inches. Okay, so it makes sense. I know order of operations says to do multiplication first. I'm going to multiply these two together, and I get 12 inches squared, and I still have the length, right? And I have 72 inches cubed equals length times 12 inches squared. I look at the side with the variable, I draw my balance scale, I do the opposite of multiplying by 12, which is dividing by 12. And I'm even going to divide the units because remember, units cancel out too. It's pretty cool. So the 12 inches, 12 and 12 cancel out, the inches squared cancel out. Remember over here, this looks like inches times inches times inches over inches times inches. So those pairs will cancel out. The units that will be left will just be inches, and 72 divided by 12 is 6. So I get 6 inches is equal to my length. And that is the solution to the missing dimension. All right, let's look at number 5. I think I'll go ahead and circle the volume. Oops, I meant to circle the volume in black, same as the other example. Okay, so there's my volume. Let's keep the width in red. So we'll do the width in red. There's my width, but I'm going to use the decimal. And then I'll put my length in blue. This is length equals. And I am solving for, oh, sorry. This is the height. That was my mistake there. I'm solving for the width. So this one is unknown in red. I made a mistake on my colors there. Sorry about that. Come on. All right. So this is the height. Height equals, and I'm going to use the 5.5 for my height. Okay. So now I can go ahead and write my equation, and I'm going to write that 1375 centimeters cubed is equal to, the length is in blue, it's 20 centimeters. The height is in purple, and it's 5.5 centimeters. And my width is my unknown, so that will be W. So there's my equation, right? So I can't, I don't want to undo the math yet because I've got some simplifying to do. I want to first do the 20 centimeters times 5 centimeters. So when I do that, I'm going to draw my balance scale. I'm going to multiply these two numbers together, and I get 110 centimeters squared times the W. And the side with the volume didn't have any changes to it, right? Oops, this was cubed. And I look at the side of my variable, and I'm going to undo multiplying by 110 centimeters squared, which is dividing by 110 centimeters squared. So I divide both sides by 110 centimeters squared. The 110s cancel out. The centimeters squared cancels out. I'm left with the width is equal to 1375 divided by 110. I get 112.5, and just the same way that the inches canceled out, the centimeters are going to cancel out, and that leaves me with 112.5 centimeters is equal to the width. So that was my missing dimension. The width is equal to 112.5 centimeters. All right, that's it for the lesson. Sorry it was a little bit long, but there's quite a bit to cover for volume. Remember, length times width times height, and that only works for the rectangular prisms and finding the volume.